So now I just want to show you a couple more examples of ways in which you might see the Michael addition reaction presented, things that might make it seem like it's tricky. So here is one example. This is our conjugated system, our acceptor, and we are going to react it with a lithium dialkyl cuprate, which is a reagent that you've seen before when you were looking at reactions of carboxylic acid derivatives. The hardest part for me with Michael addition reactions is that I usually don't recognize them. When I see them, the reagents are ones that are used in a variety of different reactions, and the Michael addition reaction in itself is not super common. So the hardest part about the Michael addition reaction is just knowing that I'm looking at it when I'm actually looking at it. The biggest clue that I should recognize is the conjugation, the conjugated system, combined with a weak nucleophile. So we're never reacting these guys with strong nucleophiles like alkoxides or OH minuses or hydrides or things like that. This nucleophile, the dialkyl cuprate, is one of the ones that's listed as a common Michael nucleophile. It's the only one that doesn't really follow the standard pattern of the nucleophiles having adjacent side-by-side double bonds or triple bonds. It is going to add the R group, in this case ethyl, that's going to be the nucleophile that gets added in this reaction. And remember that nucleophile is always getting added to position number 4 of the conjugated system, or number 1, depends on how you go about numbering it. 1, 2, 3, 4. 1, 2, 3, 4, and I've added the ethyl from the dialkyl cuprate onto my carbon number 1. So that's one thing to look out for. Now, second thing, this right here tricks me every time. This is a really sneaky way of somebody presenting a Michael addition reaction to you. So this is going to be written as 3 steps. Step 1 is this ethoxide. Step 2 is this conjugated aldehyde, alkene thing. And step 3, hydroxide or hydronium ion. And when I look at this, like I see this guy right here, and there's nothing about that makes me think that I'm looking at a Michael addition reaction. I'm trying to do like a malonic ester synthesis or something. Like I'm just lost. This is a really, really sneaky way of presenting the Michael addition problem. Normally, the conjugated aldehyde thing, this guy, normally is written on the left-hand side of the reaction. And this thing, which is our nucleophile, it's normally written on the arrow. So first trickiness here is that our reagents are written in a place where we don't normally see them. The third tricky thing is that the nucleophile is not nucleophilic yet. It's got this base on here that it wants us to transform the nucleophile into an actual nucleophile. So this reaction has just been really, really disguised, cleverly disguised, makes it very sneaky. This reaction, we are adding the diester to the conjugated system, 1, 2, 3, 4. We're adding it to what I've labeled as carbon number 4, and it's being added from or at that carbon that's in the middle of the 2 carbonyl groups. So, man, you know, if you see a problem like this, I hope that it doesn't trick you the way that it tricks me. But that's, you know, there it is. There's the product. None of the ones on Sapling are tricky like that. And I certainly am not going to write a question that's tricky like that, because I don't think like that. But if you come across it somewhere else, there it is.